Welcome to The Explainer. Today we're diving into the ideas behind Think Python, a book that makes a pretty bold claim. The real point of programming isn't just about learning to write code. Nope, it's about totally rewiring the way you think. So let's kick things off with a big question, maybe a little weird. What is programming really? I mean, is it science? Is it engineering? Could it even be poetry? Well, as you're about to see, the answer is kinda all of the above. You see, the book's first big idea is that the real skill here isn't just memorizing a bunch of commands. The secret, the real magic, is learning a new way to think, a super structured way to solve problems. The author, Alan Downey, really hits the nail on the head here. He's not just trying to teach you a programming language, he's teaching a whole new mindset. It's a powerful way of thinking that actually blends the best parts of a few different disciplines. To really get this new mindset, you first have to understand the huge difference between the languages we speak every day, natural languages, and the languages we use for programming. Our languages are kind of messy, right? They're full of ambiguity and metaphor, but formal languages, they're the exact opposite. They are designed to be completely 100% literal. And in a formal language, every little detail matters. A comma in the wrong place, a typo, it can change the entire meaning. You can't just skim it like a novel. You have to learn to parse its structure, to read the logic like you're reading a map. It's dense, it's precise, and that's what makes it so powerful. Okay, so if we're learning this brand new, formal way of communicating, what does the thinking process behind it actually look like? Well, this new way of thinking is this amazing hybrid. It pulls together the absolute precision of a mathematician, the design and build mentality of an engineer, and the evidence-based, tested-out approach of a scientist. It's all rolled into one. So how does all this work in practice? You might be thinking that a programming language has, thousands of commands you have to learn. But the truth is, the foundation is surprisingly simple. Think about it. Almost every single program you've ever used, I don't care how complicated it is, from your web browser to a massive video game, is built from just 5 basic kinds of instructions. Input, output, math, checking for conditions, and repetition. That's literally it. And that right there is the big reveal. The entire complex art of programming really comes down to one core skill: breaking a huge, messy problem down into smaller and smaller pieces until each tiny little piece can be solved with one of these 5 basic moves. Of course, anytime you're building something, you're going to make mistakes. It's just part of the deal. In programming, we call these mistakes bugs, and honestly, dealing with them is a whole skill in itself. So here's a crucial mindset shift. You have to change how you think about errors. Instead of seeing a bug as some kind of personal failure, a computer scientist sees it as a data point. It's a clue. The program didn't do what you expected it to, and now you have a hypothesis to test. It's basically the scientific method, writing your code. I absolutely love this analogy. It just completely reframes the whole experience, doesn't it? You're not fighting a machine. What you're actually doing is trying to give crystal clear instructions to a super literal, incredibly fast, but, kind of clueless employee. An employee who does exactly what you tell it, not what you meant to tell it. So a bug? It's not the computer being difficult. It's just a communication breakdown. So if everything is really just made of those 5 simple instructions, how on earth do we manage the complexity to build something massive like an operating system or a social media site? Well, the answer is a beautiful concept called abstraction. We use a technique called encapsulation. Just think of it like a button on your microwave. You press the popcorn button, right? And a whole bunch of stuff happens inside. Power levels change, the timer runs, but you don't need to know any of those details. You just know you can use the popcorn button. In code, we do the same thing. We wrap up a series of simple steps, give that package a name, and bam, we've created a new reusable tool. And this is where the real magic happens. We can take these new, custom-made building blocks and start combining them, composing them, to create even bigger, more powerful blocks. It's just like building with Legos. You snap a few small pieces together to make a car, and then you can use that whole car as a single piece in an entire city you're building. Which brings us right back to where we started. The way of the program is this constant dance between 2 moves. First, deconstruction, breaking big problems down into tiny, solvable steps. And second, construction, composing those simple solutions back together into powerful, elegant systems. So that leaves us with one final thought. This whole method of breaking down problems, testing your ideas, and building solutions from simple parts, It's not just for computers. It's an incredibly powerful toolkit for thinking about pretty much any challenge you can imagine. So the question is, what problem are you going to start breaking down?